Happy Saturday. I wanted to clean up some of the lecture from last week because, frankly, I think I was just too tired to explain anything. So I wanted to guide your homework problems, which will help you on the quiz. So the theorem I was using in class the other day was that if I know that the greatest common divisor of A and M is D, and I'm looking at the congruence equation AX is congruent to B mod M, if D doesn't divide B, there's going to be no solutions. In the case where D does divide B, there's exactly D solutions mod M. So I'm going to prove this later, but for now I'm going to show you how to apply this to solve a congruence equation. The one I did in class was 9x is congruent to 15 mod 24, and when I did this in class, I had numbers floating around places and it didn't make sense, and some of the numbers were incorrectly written down and then correctly used with a different number. So I want to clean all that up step by step, and I'm going to add in some more steps based on some questions you had. So first of all, A in this case is 9, B is 15, and M is 24, and D, the greatest common divisor of 9 and 24, is 3. So the first step is to determine the number of solutions, and that's going to be given to you by D. But I can't apply that theorem at all unless I know that the value of D divides B. So that's the first thing I need to check, which is does 3 divide 15? And the answer is yes. So on the notes, which I presented in class, I had a 3 divided by 15 hanging around. That's what I was doing. I was checking that I can actually apply that theorem. So since that's true, I can tell you that there's exactly D solutions mod 24, or there's going to be 3 distinct solutions mod 24. So the goal is to find one solution. Once I find one solution, I can find all the other ones by adding a particular modulo. So I'm going to break down the original equation in congruence form, and this was a step which was missing in my notes. Take the 9x congruent to 15 mod 24 and break it down. That means that 24 has to divide 9x minus 15, or that 9x minus 15 has to be a multiple of 24. I can actually reduce that equation by division, by dividing through by 3. So if I divide through by 3, I get 3x minus 5 is 8s, which can be recapitulated back into an equation of congruence form as 3x is congruent to 5 mod 8. Notice that I didn't have to take this extra step of breaking it down into an equation. I'm really just dividing out 3's across the congruence equation. So you can skip this step. I just wanted to fill in and show you where I was coming up with the 3x is congruent to 5 mod 8. So now you have a new equation, and I called this A tilde x is congruent to B tilde mod M tilde, where the A tilde is 3, the B tilde is 5, and the M tilde is 8. What I'm going to do next, and this was completely missing from my notes, is that I'm going to solve a different congruence equation. I'm going to solve the congruence equation A tilde x is congruent to 1 mod M tilde. And I'm going to do that by listing. So if I plop everything in, I'm really trying to solve the congruence equation 3x is congruent to 1 mod 8. And then that's equivalent to saying 3 must divide 1 plus 8s. And that's because if I break it down into the definition of congruence, I get 8 divides 3x minus 1, or 3x is equal to 1 plus 8s. So I can make a little list, and I just did this on Excel so you can see, and I get quickly that s equals 1 yields me a solution. So at s equals 1, I get 1 plus 8s is 9, which is divisible by 3. So if I translate that back into congruences, what I have is 3 times 3 is congruent to 1 mod 8. So what I have now is two pieces of information. 3 times 3 is congruent to 1 mod 8, and I have this other congruence equation, 3x is congruent to 5 mod 8. So I copied the first piece of information called 1, and I labeled it 1, and I copied the second piece of information and called it 2. So what I'm going to do now is I'm going to take both sides of equation 2 and multiply it by the solution of 1. So I'm going to take that 3x congruent to 5 mod 8, and I'm going to hit both sides with a 3, because that's what I found is congruent to 1 in equation 1. Why am I doing this? Well, 3 times 3 is 1 in the world of modding 8. So I can just replace the 3 times 3 with 1. And that's why I went through this particular maneuver, because I want to change that coefficient in front of x into a 1. So now I have x is congruent to 15 mod 8. By the way, 15 is larger than 8, so I can reduce this 15 into the numbers between 0 to 8, which gives me 7. So I always want to reduce whenever I have a mod into the first few representatives. And this is I use the word reduce because it's very similar to the idea of reducing a fraction. So 15 is too large, it's not the right form, you scale it back to 7. And how did I get that 7? Well, 15 divided by 8 has a remainder of 7. That's where that comes from. So where are we now? We have one solution. That 7 that I found is actually one of the solutions, and that's all I need. Remember, that was the goal, to find one. I can find the other solutions by adding multiples of m tilde, and in this case, m tilde was 8. So my second solution is found by taking 7 plus 8, and the combination gives me 15. That's my second, that yields me my second solution. I'm going to express it correctly in the next step. Then I take 15 and add 8 more to it, which gives me 23. Notice if I take 23 and add 8 to it, I get something over modulo 24, which is over the range of where I'm supposed to find solutions. So now the next step is to take my answers that I found in step 6 and express them as equations mod m. M in this case was 24. So I take the 7, the 15, and 23, mod 24. One tip is at this step, we can check whether one element from each of these solutions actually works. So original equation was 9x is congruent to 15 mod 24. That's what I was trying to solve. I actually just grabbed the b value in each one of these congruence equations, which is a valid element from that set. X is equal to 7 will yield me 9 times 7 is 63 on the left-hand side of the red equation. And if I subtract the 15, I get 24, and that certainly is divisible by 24. So yes, it works for the first equation. If I take 15 and plug in to 9 times 15, I get 135. So the left-hand side of the red equation is 135. Subtract off 15, I get 120, and that's also divisible by 24. So that's a valid solution. If I take x is equal to 23, and I multiply 9 by 23, I get 207. 207 minus 15 yields me 192, and 192 is also divisible by 24. So each one of these solutions fits in the original red equation. Another tip to check is that all of these three numbers, 7, 15, and 23, should be smaller than my modulo, which was 24, and greater than 0, which they all are. You should get 3 of them at the end of the day, and we did. So that's another cross-check that we got everything.